problem 28. Use the molecular art to write a balanced equation for the given reaction. So we got a diagram of what happens here. And to write a balanced chemical equation, we need to know what the chemicals are over here that you're starting with. So these are the reactant chemicals that you're starting with, and those are the product chemicals that you're ending up with. And remember, you can use the figure 2.3. You should have memorized the first four, the four big ones, right? So the red ones are oxygens, the blue ones are nitrogens, and we can look at each particle. We got these four particles; they're all the same. Okay. And then you got those two particles. Those are the same. So you got two different substances over here. Two substances for the reactants. So these are O2. You got two oxygen atoms connected together. So we have O2. That's one of the reactants. And then what's the other one? You got NO. NO. One nitrogen, one oxygen. So we can write that as NO. So you got NO plus O2, and then what does that turn into? Well, on the product side, you got one nitrogen connected to two oxygens, and they all look like that. And so there's only one substance in the product side, and that's NO2. And that's probably sufficient to answer this question. If it were me and being the nerd that I am, and maybe I shouldn't put it that way, just being more particular and wanting to be more specific, I would want to make sure this equation is balanced. Okay, and if you count up the oxygens on the left, you got 1, 2, 3, and then you only have 2 over here. And so you want to balance this. So I'd want to put a 2 here and a 2 there. Okay, now you got 2 nitrogens, 2 nitrogens, 2 plus 2 is 4 oxygens, and oxygens. Okay, and that's better. And I also might notice that the proximity to these are far apart, so the particles are all far apart. I'd probably say that this is happening in the gas phase. Okay, so that's a lot more detail.